Okay, now in dihybrid crosses, already you are familiar. In dihybrid crosses, we normally go for two traits together. We determine the effect of two traits at simultaneously, correct? So in this question, if we see, in this question, that is question number 3, okay, what is there? In mice, allele H for the colored fur is dominant over white fur, okay? Similarly, allele N for the normal behavior is dominant over Wardzic behavior, okay? Or a form of discoordination. I gave you the example before. Discoordination, it is just like the mice is acting like drunk, okay? So give the general. Yes, what is the next question here? Give the parents in each of the following crosses. What is the mean genotype, in fact? Okay, genotype of the parents in each of the following crosses. Now the point is, for example, I told you before, in normal dihybrid crosses, once we are raising generation up to F2, what is the outcome?
3 to 1.
Normal. In normal set, it is no F2. In F2 generation, it goes to 9, 3, 3, 1 ratio. Are you familiar with this 9, 3, 3, 1 ratio?
No. So is it always 9, 3, 3, 1?
Yeah, no, first of all, you just have to give me, you have to give your consent that you are aware of 9, 3, 3, 1 ratio or no?
No.
Okay, first, whenever the dihybrid cross is there, there is always 9, 3, 3, 1 ratio, correct?
Okay.
Now, once we are going for the practical analysis, so this is actually theoretical value, okay? This is theoretical value. So once we are talking about the theoretical value, so in theory, it should be 9, 3, 3, 1 ratio, but once it comes to the reality, it cannot be, okay? But you just remember, number 9 is predominant. Number 9 is predominant mean both alleles, like for example, a dominant fur and a normal behavior. This is dominant trait, yes? So it will be having 9 out of 16. The percentage you can count. The percentage you can count, okay? So here, this is 9. Normally, it should be 9. Next will be, one will be the dominant trait. For example, a normal trait is there, which is colored. And Wardzing is a recessive trait, correct? So there will be, how many? There will be 3. Similarly, normal for the coordination and white fur, it will be, again, it will be 3. And both recessive, it will be 1. So total is 16. The total outcome of dihybrid cross is 16. You know, like normal Punnett square for monohybrid cross, this is 4. Yes, 3 out of 4 or 1 out of 4, like 3 to 1 ratio. You are very familiar. You have done this thing in grade 11, GCSE, or in your grade 11, you have done it. Monohybrid crosses, isn't it?
Yeah.
So here we are talking about dihybrid cross. Dihybrid crosses are always 9, 3, 3, 1 ratio. Now, once we are looking at 1, which is, so obviously, look here, what is this one? White and Wardzing, yes?
Yes.
So both traits are recessive. So it's mean in order to have these traits, these two traits, both, all the alleles should be recessive. So if I write for them, what will be the phenotype of this? The phenotype, the genotype, in fact, it will be HH4 because they are white, correct? And phenotype for Wardzing behavior, it will be what? Small n and small n. This will be their genotype.
Yes.
Correct? These 3 genotype, these 3 here, wait, I will be using another curve so it become more obvious. So for these 3, what will be the genotype for these 3? Can you tell me? These 3 are 15 are colored and Wardzing, okay, and 11 are white and normal. So white and normal, if they are white and normal, so what will be their genotype?
White and normal is white.
It can be white. Obviously, it will be like this. Both are small. Like this. Oh, and normal will be either it can be capital N,
Or double N.
It can be capital N and small n. So these are the possible genotypes.
Yes.
Okay. Now, once we are talking about these now, they are colored and Watson, correct?
Yes.
No, sorry, they will be colored and Watson, correct? So one is dominant and one is recessive. So obviously this will be the vice versa. There are three. So it will be what? It can be either H, capital H, or it can be capital H and H. Yes, so it's mean both are colored, isn't it? And next trait for the Watson, it is obviously, so it can be having this genotype. Capital H, N, small n both, okay? Or capital H, small h, and this small 2n will be there. So in this way, this is the genotype of these kids, like 15 colored and Watson, correct?
Yes.
Remaining, which are 9, they should be having what? Either they can have capital H, capital N. This can be one possibility. Second possibility, it can be capital H. So there are many possibilities, okay? This capital N, this is the second possibility, yes. What can be the third possibility? Capital H, small h, capital N, small n. So there are plenty of possibilities for this, because if they have one dominant allele, so they can make this part, isn't it? You are familiar with this thing.
Yeah.
Now the conclusion is there. Look here. The question is, what is the phenotype? In fact, we have to predict the genotype of the parents.
Yeah.
We have to go back. So once we are going back, genotype is always this kind of 9:3:1 ratio is possible only. I mean, we are getting all the four combinations. Look, the important thing is in the offsprings, we are getting all the 4 possible combinations. So in order to get all the 4 possible combination, both the parents, they should be heterozygous for their traits.
Oh, so it has to be.
So it should be like both parents, they should be heterozygous for their traits. So it will be only this chance can come, this result you can get only if the both parents are having heterozygous with this. So capital H, capital N, small n. Only if the both parents are having this genotype, only these 4 possible combinations are there. If you disturb this, all 4 are not possible. So forget about 9:3:1 ratio. This is a simple one sentence answer. These 4 possible combinations are possible once both the alleles or both the heterozygous.
Sorry, continue.
Okay. So they are both heterozygous.
Yeah, okay. So both are.
You got it?
Yeah.
Both should be the heterozygous. This is the condition.
Okay.
Okay, I'm removing this. I'm done with this question, okay?
Yes. Okay, what about B?
No, I'm done with this A.
Okay.
I'm removing it because it is already recorded with you, so you can play it again. Second thing is B. A colored normal female mated with white Watson male. Correct? White Watson male. So white Watson male is what? Recessive for its trait, yes?
Yeah.
So white Watson male will be, it will be having this genotype, isn't it? All 4 alleles are recessive, correct?
So it'll be small h, small n.
Small n for the male, because this is the only possibility.
Yes.
Okay, so whenever in any cross, one parent is homozygous recessive. Okay, so it is known as a test cross. So if this is homozygous recessive, this is actually the point. Okay, you have to remember this thing. We are already aware of this homozygous recessive. Once one parent we have homozygous recessive, we are already aware that this is homozygous recessive. If we know this, we can predict what is the genotype of the other parent, whether other parent is also homozygous recessive or it is the other parent is heterozygous for its trait.
Yeah.
Okay, so now this is a colored normal female. So we are not knowing whether the colored normal female is either it is capital H and capital N and small n. If it is capital N and capital N, yes, this is the phenotype, in fact genotype, or its genotype is like this like this, and then it will be having this thing like this. So we are totally unaware of the fact.
Yeah.
Correct. So if we cross this with this, what will happen? All the kids, if we cross the homozygous dominant parent with homozygous recessive parent, all the kids, they must be colored and normal. Because you understand, this is the most important. So this is actually, this term is known as test cross. So if the female, she was homozygous homozygous dominant, mean all alleles are homozygous, capital H, N, capital N and capital N, correct? So if we cross this with the male, all the kids should be colored normal. But what is the result we are getting? 7 normals are 7 colored watching, 8 colored normal, 7 colored watching, 9 white normal, and 6 white watching. What does it mean?
That's not the parent. So
The female is not homozygous dominant, she is heterozygous dominant. That's all. So this is the answer for this question. So this is actually known as test cross. For the test cross, we actually always cross it with a homozygous recessive. Okay, and then we want to find out whether the genotype of the other parent, whether that parent is also homozygous recessive or dominant or heterozygous dominant. So this is the answer. So you can stop the record first.